for this one last presentation of today. So I'm Juho, one of the two meteorologists here, and I've been responsible for developing the Mesoscale coupling tools in Winsin. And so what is mesoscale, mesomicroscale coupling? So in the ideal world, we would like to have one atmospheric model that's able to simulate all the atmospheric scales from the global scales down to the microscales, but such a model would be immensely expensive computationally. So what the atmospheric modeling community has done instead is to split the flow modeling problem into several different models that are good at capturing some aspects of the atmospheric flow. So starting from the global models, many of you are familiar with the global reanalysis datasets like ERA5. We can use those as boundary conditions for these limited area or mesoscale models that are good at capturing the small scale weather effects and especially the thermally driven flows at scales of a couple of kilometers. But that's still not good enough for microsighting turbines in complex terrain. So we have these CFD or other high-resolution microscale models. But those microscale models, they lack much of the physics that is required to model the mesoscale flow phenomena. So the question in a mesomicroscale coupling is, how do we create like a best of the both worlds model that's able to capture the high resolution of the CFD models and the capacity of the mesoscale models to simulate these relatively small scale weather phenomena, which do occur at the scale of a typical wind farm. So a brief history lesson. We had an industrial PhD student a couple of years ago here called Pablo Duran, who did excellent work on developing these mesomicroscale coupling tools further. And he published 3 papers describing the method and also validating it against observational data, which you can find either through this link or through our web page. So in brief, how this method works is this method couples the mesoscale and the CFD microscale model by modifying the boundary conditions of wind speed and temperature that you use for the CFD model runs. The most basic application uses WRF mesoscale data. This also, so this method has been tested with WRF data, but the method is more general and can be used with other mesoscale data as well. But if you have a WRF mesoscale run and you output the mesoscale state at certain intervals, if you run the simulation, say for 1 year, and you output for every 1 hour, then you have almost 9,000 different mesoscale states. But it's not computationally feasible to use all of those 9,000 boundary conditions for the high resolution CFD runs. So you have to come up with some kind of way of aggregating the mesoscale data. And we have 2 ways of doing the aggregation. The most basic one is to simply look at the direction of the wind of the boundary layer inside the mesoscale simulations, and then take the corresponding averages. So if you simulate 12 to 36 wind sectors, you take the corresponding 12 to 36 directional averages of the mesoscale runs, and you impose them as boundary conditions for Winsin. So what we modify at the boundary is always the profile of the wind, but optionally you can also modify the temperature profiles as well. So what you can do these days in WinSim 12 is you can take the low resolution 1 to 3 kilometer mesoscale data, and you can use that to create downscaled high resolution wind resource map. But there are a couple of caveats to this method. So this, as was shown by Pablo's validation work, it works pretty well for many of the sites. So it's completely okay if you as users use this method that's already available in WinSim. But there are some limitations. So if you enable temperature, like atmospheric stability, those runs can be very difficult to convert. If you have multiple stabilities coming from the same sector, or if you have unstable atmospheres, it's quite difficult to find convergence. And even if you do find convergence, then the simulation results are not necessarily very realistic. And the other thing relating to the boundary condition coupling is that it's difficult for the microscale model because it lacks much of the mesoscale physics. It has difficulties of maintaining a reasonable mesoscale state. So here are the figures on the right show an example of a site where you have tall mountains on the side and a valley in between the two mountains. And during stable nighttime, you have a stable atmospheric layer with high wind speeds in the valley. And that's captured by a high-resolution WRF simulation, which is bottom left corner. But if you use the corresponding boundary conditions for WinSim, it gives you a very different, probably unrealistic description of the wind field. And this method is also, the boundary condition coupling method is difficult to use with many of the existing mesoscale datasets like the new European Wind Atlas or the Global Wind Atlas, because they don't include all the necessary variables required for the coupling, and they only store the data for the lowest 250 or 500 meters, which is not enough because you have a CFD model that can have a model top of several thousand meters high. And this method is also difficult to use for screening, so greenfield sites. So what we want is a method that's easily able to converge, is able to maintain the mesoscale state, can be used with New European Wind Atlas and Global Wind Atlas, and can be used for greenfield sites. So those were the design criteria for the alternative approach to the mesomicroscale coupling that we have developed. And the overall design goal was to create something that's better, more accurate than the standalone WinSim CFD run. So that was the main design criterion. So what this method basically is a small upgrade to the widely used virtual metmast coupling approach. So in the virtual metmast approach, you take in the most naive approach, you take the mesoscale data as a time series, and you impose that as a virtual climatology inside the WinSim run at the exact location of the mesoscale data point. But because the terrain and the roughnesses can be very different at the resolution of the mesoscale model and the microscale model, then if you have the mesoscale virtual climatology at some kind of a hill that is not represented inside the mesoscale model, or in a valley, then you get very different and inaccurate predictions for the wind resource using that naive virtual metmast approach. So a simple way of handling some, but not all of that uncertainty is to do the coupling instead of taking the mesoscale data at the exact location of the mesoscale grid point. What we do in this approach is we do the coupling based on the spatial averages. So the goal is to create a model that uses the WinSim CFD to simulate the short scale or small scale flow variability away from the mesoscale mean. So how we do it is illustrated in this cartoon figure. So basically you have, so in the x-axis you have the horizontal dimension, and on the y-axis the wind speed, and we simply get the mesomicroscale coupled downscaled wind speeds by scaling the large scale mesoscale wind speeds by how much at the exact location of the mesoscale grid point, how much the wind speed varies in the microscale from the large scale microscale mean. So it's as simple as shown as, almost as simple as shown as this equation. If you have 2 dimensions, which we do have in the 2 or 3 dimensions, then you have to use vector calculus, and it gets a bit more complicated. But the underlying idea is the same as in this one-dimensional example. And we can see, using, for example, New European Mid-Atlas experiments, how this method works. So we take, for example, the site in Kassel in Germany, which has 1 metmast and 4 lidars separated by many kilometers from another in complex terrain. And we run a 50-meter WinSim CFD with neutral atmosphere, so that's the base CFD run. And we take now the new European Wind Atlas mesoscale data, which has been computed at 3-kilometer resolution. And we perform this mesomicroscale coupling, and we compare that to the standalone CFD run without any coupling or any post-processing downscaling. And this figure shows the horizontal cross-validation errors for all the 20 possible observational pairs as a function of distance between the observations. So what the perfect prediction is the one-to-one line. So anything that deviates from that is a flow model error. And for short spatial scales, say less than 6 kilometers here, you don't see, which is twice the resolution of the New European Wind Atlas, you don't see much of a difference between the 2 modeling approaches. But especially when you get to these large spatial scales where the flow is resolved by the New European Wind Atlas mesoscale model, you start seeing great improvements in the flow modeling performance. And we can repeat the same exercise for 5 European sites with total of 86 metmast pairs. This figure shows the mean and the variability from the mean in the same format as the previous figure. So blue line shows the standalone CFD, and the red curve is the downscale mesomicroscale coupling. And at short scales, there is not difference between the two approaches. So at least what this mesomicroscale coupling does, it does not degrade the simulation quality at the short spatial scales. And at large spatial scales, you start seeing great advantages to using the mesomicroscale coupling into scales that are resolved by the mesoscale model. And here you see what the typical improvements are in terms of the root mean square errors for the different sites. So you see something between 20 and even 50% for some sites improvements of the flow modeling accuracy. So scaling approach, relatively consistent improvements over the standalone WinSim, especially at those large spatial scales. And this allows you to do fast downscaling, so no convergence issues. And it allows us to run greenfield sites, so screening and also allows us to also downscale each of the mesoscale time steps. So now if you have those 1 hourly mesoscale outputs for 1 year, it's not a problem using this approach to downscale all of them and get like a time series output at any arbitrary location inside the domain. And it can be applied with datasets like New European Wind Atlas, a global wind atlas. But there is no perfect way of doing the mesomicroscale coupling. So this is definitely targeted for the wind resource maps. The turbulence fields are not scaled. So if you want to do accurate turbulence modeling, and then the boundary condition coupling approach that was developed by Paplonis in Vincent 12 should be probably used. But these are alternative approaches which can both be used. So in summary, the MMC is in active development at Vincent and extends Vincent's capability to sites with very complex mesoscale flows. And importantly, it now also allows us to do screening, also greenfield sites. And we are working as fast as we can to get these mesomicroscale coupling tools to the cloud. But as that's going to take some time, we are now offering the mesomicroscale coupling as a consulting service. So feel free to reach out to Nanda or any of our consultants if you want to do, if you have sites in complex mesoscale flows and you want to do hopefully more accurate flow modeling. And we'll be happy to take your requests. Right. Any questions?
Thanks a lot, you. So as far as I can see from the Q&A and the chat, there are currently no questions on your presentation. Correct me if I'm wrong. No, it seems it's no questions so far. So now actually we have one. So yeah, we have Ryan at Ventient. So he's asking if is the MMC consultancy offer free for the accelerator users who cannot use it on the desktop version?
This is something that needs to be discussed with the consulting team. I cannot.
I can jump in here. Hi Ryan, it's good that you're there. No, it's not free, unfortunately. But if you have something in mind, we're happy to take a conversation with you to see if we can find a good mutual arrangement. But it's not for free. I'm sorry.
Okay, thanks. So if there's any more questions, now we have some questions coming in. So please just post in the chat if you have questions on Juho's presentations. So I'm gonna pick up the question from Utku Turkilmas next. So for MMC, would you still recommend using atmospheric stability, or would you regard that it's covered by mesodata, so neutral only run?
Yes, this is a question which we are exploring and which we don't have a comprehensive answer to right now. But with you can optionally enable the temperature equation in the boundary condition coupling approach that's now in Vincent 12. And what we have seen is that when it works amazingly well. But when it doesn't, it fails spectacularly. So it can be attempted, and for some sites it definitely does improve the flow modeling performance, but that's not across the board. For some cases, it leads to horrible, much worse simulation results than the neutral ones. Yeah, so no, you need to do experiments, but it's something that definitely can be attempted, and sometimes it works reasonably well. variable. Yeah.
Great, thanks you. I'll move on to the next one. So this is from Andreas. Would you be able to share an implementation example of the MMC? So I guess.
So like we have said with Hundammer, or so the we have. So are you can't talk, but the if the question is about like a sample site, then yeah, it would be good to have a sample site of the Mesoscale coupling. Unfortunately, we did not have enough time to include it in Vincent 12. But if you reach out to me through the Vincent support, I can give you a sample Mesoscale data for Hundammer that you can then use to try to see how the MSC works for that site. Yeah, if there's.
Yeah, thanks you. So we have a couple of more questions coming in, so I guess we have time to take some of them. So first, this one is from Giorgio. So he says that he's sorry, but he missed the first slides. So he's asking if the Meso is a wharf model run in-house at Winsim.
Yeah, so for the cloud implementation, at some point, yeah, we are going to have an in-house wharf run. So we have run the wharf on our desktop servers in Vincima. So the implementation is ready, but delivering that to customers at scale is difficult without the cloud computing power on the accelerator. So we've been mostly working on sites that are covered by sites that are in Europe and covered by the new European wind atlas. But yeah, also we plan on including an option on the accelerator to upload your own wharf data that you can use for downscaling in conjunction with this procedure.
Great, thanks you. So we have one more at the moment, so just keep the questions coming if you have more questions for you. The next one is from Petros. What are the necessary physical properties that the Neva netcdf file should include in order to be utilized by Winsim MMC?
Yeah, so the new European wind atlas, so there is a hidden feature inside the Winsim 12 that makes them work with the new European wind atlas, but that's highly experimental. I can reach out to you can reach out to me via the support email if you want to try it out. But what we want with the new European wind atlas is that it be used in conjunction with this scaling approach, which is more suitable for the new European wind atlas data because it's limited. It's only up to 500 meters and it doesn't include pressure gradient information, for example, which is pretty necessary. But if you want to try it, yeah, in Vincent 12, yeah, there is an experimental feature. You reach out to me via support and I can give you further details. But that's yeah, we did not release publicly because we did not go through a good enough testing procedure for that. So it's experimental, but I'm happy to talk about it more over support. Yeah.
That's great. I guess you will have some incoming support cases for the next couple of days.
Yes.
Yeah. So that's good. Okay. So I think, yeah, now we have been through the questions from the chat and the Q&A is no new questions. So I guess you have answered the ones we have you. So thanks a lot for that.
Thank you. That's great. And Vincent, there are no other more general questions or things related to previous presentations?
I know there was one question that popped in just as Ingo ended his session from Milan Svart, and it was I think it was for Ingo. It was
Okay.
if there was any consideration for the applicability of neutral modeling. So I'm not completely sure. So I guess Ingo can take over if he understands the question. If not, we will just write it out. I think maybe that would be the best to provide a written answer to the questions we have not been able to answer during the sessions.
Yeah, I've been, we're coming to an end here now, and I've been impressed by the engagement in the chat. And we were able to answer some, but not all. But we are going to follow up with you after this and respond to all the emails. Now, for example, there was a question about, what about offshore? This was on the original agenda, and this is true. But we did cut it out of the program today, given a number of other topics. But we're going to come back on offshore. It's something we are working on and would like to kick off a development project quite soon. But so as I said, we're going to come back on all the questions. I'm hoping to be able to post all the videos and presentations sometime next week. And so with that, I will send you an email with the links to those, as well as the knowledge base. I want to come back to the knowledge base and really encourage you to explore it, because as I said, if you want quick answers, that's probably the best way. And I think it's very useful as a learning tool as well. So please do explore that. I want to thank all the special guests and speakers once again. So Tore from Geodata, Ove from Statkraft, Mutali from Harmatin, and Ingo from Geosphere, as well as the entire WinSim team. It's been a real team effort. So I hope, sharing the knowledge, learning something new and interesting, maybe get some inspiration for some new use cases, as well as getting insights into the innovations coming. So I hope you found it useful. Stay in touch. I'm going to share one last slide here. On the right-hand side, you can see a number of ways you can stay in touch. I also want to mention, for those who are already existing WinSim users and are planning to renew, we are running a special offer for those who want to go for the longer term. If you buy 3 years subscription at the moment, you will have to pay for 2. If you have any specific questions, anything you want to ask about, whether it is any of the technical presentations or any of the other products, consultancy services, or accelerator, please let us know. And look for a number of emails in the coming period, very shortly, about all the materials from this presentation, and then later on a notification about the release of accelerator pre-processing. So with that, unless, Vincent, there are some very last questions we can answer?
No, it's no further questions.
Okay.
So I guess it's a good place to end. Okay,
great. Thank you, everybody, for attending. Hope to see you soon and have a great continuation of your day. Bye-bye.
Have a nice day. Thanks.